Okay, so today we're going to do section 9.1. We're going to start looking at some trigonometry. So first we need to review some basic vocab just to make sure we understand everything that's being said. So a line is just a shape that goes in two directions infinitely. A line segment is a piece of that line that has endpoints. A ray has one endpoint and then goes in one direction infinitely. And then an angle is a space made up of two rays. So the two rays are the sides. They meet at the vertex. And then the measure of rotation is that angle. So the initial side is where you start. And then the terminal side is where you end. And those terms are going to help you with drawing things later on in this section. Degrees. So in a circle, we have 360 degrees. 1 degree is written with that little symbol like that. An acute angle is between 0 and 90. A right angle is exactly 90 degrees. An obtuse angle is between 90 and 180. And then a straight angle is exactly 180 degrees. Angles can be complementary or supplementary. The way I remember the difference is complementary. You can turn that C into a 90. And supplementary, you can turn the S into an 8. So you have 90 degrees for complementary angles, 180 degrees for supplementary. So if we're trying to solve this, these two have to add up to 90 degrees. You combine like terms, divide both sides by 9, and x equals 10. Now, if the problem then wants you to find the measures of the angles, you'd plug 10 in for x. So 6 times 10 is 60, 3 times 10 is 30. Supplementary, we do the same thing. We're just adding up to 180 this time. So we add the two angles together. Combine like terms. Bring the 5 over. And then divide both sides by 5. And x equals 35. So then if we wanted to find the angle measure, we'd plug it in. So 3 times 35 is 105. 2 times 35 plus 5 is 75. Degrees can be written and broken down into degrees, minutes, and seconds. So 1 degree is written with the little circle sign. 1 minute is written with an apostrophe. And it's the equivalent of 1/60th of a degree. There's 60 minutes in a degree. Seconds has the double apostrophe there. And that's 1/60th of a minute, or 1/3600th of a degree. So 60 seconds in a minute, 60 minutes in a degree. We can go back and forth between the degree, minute, second form and the decimal degrees. On your calculator, we're going to practice typing these in, and then I'm going to show you how to do it online if you don't have a calculator. So first you'd hit 12. Then you're going to hit second, and this apps button here says angle above it. You have your degree and minutes. So we'd hit enter for the degree. Then we do 42, second apps, go down to 2 for the angle. And then seconds is a little bit different. Right above the plus sign, you have the green tick marks there. So if you hit alpha plus, it'll put the degrees there. So now that we've written it in degrees, minutes, seconds, the calculator will spit out the decimal form. So if you want to try the other one, 43, second apps, enter, 2, second apps, 2, and then 15 alpha plus. And that gives you the decimal form. Now to go the other way, so let's say we typed 34.817. We're going to go back into that degree menu, and we're going to choose number 4, convert to degrees, minutes, seconds. And then your calculator will spit out the degrees, minutes, seconds. So if you want to try the other one, second, apps, 4, and then it gives you the degrees, minutes, seconds. Now, if you don't have a graphing calculator, you can go to this website, and you're just going to enter the degrees, minutes, and seconds right there. So I'm going to use the top one on the calculator. We had 12 degrees. Come on, what are we doing? Is this not going to let me? Nope, I guess it's not going to be active. Hold on. Well, if you entered the 12, the 42, and the 38, and then hit convert, it would spit out the decimal degrees right here. And then to go in the other direction, you'd hit the swap button. So let's go try to find that website, rapidtables.com/convert. I think I have this one right here. Yeah. So if I did that, it'd be 42, 15, and then I'd hit convert, and it would give me the decimal readout down there. If we did 43 to 15, I wrote the wrong one the first time, convert. Now, if I want to do the other direction, I hit swap, and I type 34.817, convert, and it'll give me the degrees, minutes, seconds. So I can also do that with 25.216, convert, gives me the degrees, minutes, seconds. All right, let's go back to here. Okay, if we wanted to add these up so we can do operations with degrees, we're just going to type them in the calculator. So 51 degrees, 29 seconds, or no, minutes, 15 alpha for seconds, plus, then we do the other one, 32 degrees, 46 minutes, 13 seconds. Nope, that's not right. 13 seconds. And then it'll give us the decimal degrees. If we want to turn that into decimals, minutes, degrees, or degrees, minutes, seconds, we need to do second answer. So second, and then the negative sign pulls up your last answer. And then turn that into degrees, minutes, seconds. It'll do that for you. So you guys try the subtraction one. All right, so 90 degrees minus 73 degrees, 12 minutes, 10 seconds. And you can just put the degrees, minutes, seconds right here and not get the decimal degree. But if you forget, you can always go back and do it. Ugh. Second entry, delete. What is going on? All right, so I'm going to try this again. 90 degrees minus 73 degrees, 12 minutes, 10 seconds. And then you can turn that into your decimals. On the calculator, we're going to use this website, planetcalc.com, or on the computer, I mean. And then, where was it? /951, I think it was. Okay, 915. It would help if I typed the right numbers. 15. Enter. Then we scroll down And we can just do the adding and subtracting right on here. So if we deleted this and we did those same problems we did before, 51 degrees, here you're just going to use a period as the degree, 29 minutes, and I think it was like 15 seconds, plus 32 degrees, 46 minutes, and we'll say 10 seconds. I can't remember exactly. Hit calculate, and it'll give you the degrees, minutes, seconds, and the decimal degree. So either of those will work for you. All right. Standard position of an angle. So you're going to see problems where it says when the angle's in standard position. It just means the initial ray is on the x-axis, and then the terminal ray points somewhere out in the coordinate plane. All angles between 0 and 90 are in quadrant 1. So that's here, quadrant 1. And then 90 to 180 are quadrant 2. And then 180 to 270 are quadrant 3. And then 270 to 360 is quadrant 4. Now notice they're not brackets, they're parentheses, because the angles on the axes are called quadrantal angles. So you have your 0, your 90, 180, 270, 360, and technically this goes on and on and on forever in a circle. All of those are called quadrantal angles. Coterminal angles are called so because that terminal ray would end in the same place. So you could have a 60-degree angle, but then if you went around another full circle, it's the same terminal, but it's been 360 plus 60. And you can keep doing that forever, or you can go counterclockwise and get negative angles. So when they ask you to find the least possible coterminal angle, they want you to find one in the original coordinate. So you're looking for somewhere between 0 and 360. So if your number is positive, you're just going to keep subtracting 360 until you get to a number that is between 0 and 360. So 908 has a coterminal angle of 188. When the number's negative, you're just going to add 360 until you get to a number between 0 and 360. You try the other two, pause the video, and then watch me go over it. So this is positive, so we're going to subtract 360, and 247 is in this range, so we can stop there. And then negative 800, we're going to add 360. That's still negative, so we're going to add 360 again. That's still negative, so we're going to add 360 again. And we get 280, which is between 0 and 360, so that's where we stop. Radians are another way to measure angles in a circle. So like we have 360 degrees, we have 2 pi radians. Circumference is actually where you might have seen this before. Circumference equals 2 pi r. This is just saying, hey, those are the radians of the circle times the radius. So radians are related to the radius. You've seen them in circumference. So if the whole circle is 2 pi radians, half the circle would be half of that, which is pi radians. Now, 90 is half of 180, so 90 would be pi over 2. So all of these radians can be found by going back and forth between angles. To convert from degrees to radians, you're going to multiply any number by pi over 180. So if we were to take these numbers here, 45 degrees, we're going to multiply that by pi over 180. So if we did that, we'd get 45 pi over 180. And then both of those numbers are divisible by 45. So 45 pi becomes pi, and 180 divided by 45 is 4. So 45 is pi over 4 in radians. Negative 270 times pi over 180. Well, you get negative 270 pi over 180. Those are both divisible by 90. And if you reduced it, you get negative 3 pi over 2. And sometimes they're not going to come out even. You're not going to be able to evenly reduce your fraction. So if we did this one times pi over 180, we have a decimal on top, 249.8 pi. So that's not going to reduce evenly. So you're just going to round. So you're going to actually put that in your calculator, 249.8 times pi divided by 180. And we're going to get 4.36 radians. You guys try the other three. All right. So 140 times pi over 180 is 140 pi over 180. And that gives us, that reduces to 7 pi over 9. D. Except 9. All right. Multiply this by pi over 180. You get negative 205 pi over 180. And these are both divisible by 5. It's kind of a messy looking one. It's not as simple, but you can get an exact answer. Here we have a decimal, so we know we're going to get the decimal as our answer. So in our calculator, we would type 185.6 pi divided by 180, and we would get 3.239 radians. Now, radians to degrees are very similar, except we're multiplying by the reciprocal. So it's 180 over pi. So if we did this first one, we'd multiply by 180 over pi. Well, 9 times 180 is 1620. 4 times pi is 4 pi. The pi's are going to cancel. And 1,620 divided by 4 is 405 degrees. If we do this one, 180 over pi. Well, 180 times negative 5 is negative 900. Pi's cancel. Negative 900 divided by 6 is negative 150 degrees. And the decimal thing works the same way. We're going to do 4.25 times 180 divided by pi, and we get 243.51 degrees. You try the other three, and then watch the video when you're done. All right, so times 180 over pi. We get 540 pi over 2 pi. Pi's cancel. 540 divided by 2 is 270. Times 180 over pi. We get negative 900 pi over 7 pi. The pi's cancel. And when we divide, we get 128.57 degrees. And then, last but not least, 3.28 times 180 divided by pi gives us 187.93 degrees. So going back and forth between the two is just a simple multiplication problem. All right, this circle shows you common relationship angles that you're going to see. So 30 degrees is pi over 6. 45 is pi over 4. 60 is pi over 3. 90 is pi over 2. You need to know those four. Those four are important. You can figure out any of the others by that. So like, let's say we needed 120. Well, 60 times 2 is 120. So if we did pi over 3 times 2, we'd get 2 pi over 3, which is also 120. So as long as you know those 4 pink ones, you can find any other measure on this circle. These are reference angles that we're going to use a lot in the future. So at least memorize those 4. But this circle here will be helpful in quick reference. Arc length. So the arc of a circle is this piece between the 2 rays of the angle. To find the arc length, you're going to multiply the radius times the measure of the angle, but it has to be in radians for this to work. So if we did A, we know the angle is 3 pi over 8, so it's already in radians. So to find the arc length, we're going to take the radius, 18.2, and multiply it by 3 pi over 8, and we get 21.44. If it's already in degrees, we have to turn it into radians first. So first, we're going to multiply by pi over 180, and that's going to give us 2.513. Then we can find our arc length by doing 18.2 times 2.513, and that gives us 47.74. You guys try the other 2 and come back to the video when you're ready. So, radius is 12. 12 times 2 pi over 3 gives us 25.13. 210 degrees, we have to turn into radians first. So if we do that, we get 3.665. And then we multiply our radius by our degree in radians, and we get 43.98. This can be used on the Earth. So latitudes are those lines like this that tell you how far apart they are on the circle of the Earth. So Reno, Nevada is at 40 degrees north, and LA is at 34 degrees north, and they're vertically in line. So we want to find out how far apart they are. Well, first, we need to figure out the degrees apart. So 40 minus 34 is 6 degrees. Now, remember our formula has to be in radians. So we're going to multiply that by pi over 180. And we get 0.105 degrees, or radians, sorry. Now we can plug this in. The radius of the Earth is 6,400. And we just said our angle in radians is 0.105. So if you multiply those together, you get that Reno and LA are 672 kilometers apart. Now, it didn't come out even. I had to round. That's fine. But it's just to show you, you can use latitudes and this formula to find distances on Earth. All right, now we're going to look at sector area. So the sector is this whole chunk of the circle. So if we want the area of that, we use this formula. Again, it has to be in radians. So for A, I have to turn that degrees into radians, which gives me 0.262. Then we plug it into the formula. So 1/2 of the radius squared times 0.262 gives us 144.28 squared units, whichever those units might be. If, like B, it's already in radians, we can just plug it directly into the formula. So 1/2 times 105 squared times 5 times pi divided by 7 gives us 12,370, depending on what it has you round to. So you try C and D and come back and watch the video when you're ready. So first we need to turn 20 into radians. Then we plug our radius and our measurement into the formula, and we get 127.21. Pi over 4 is already in radians, So we can just plug these in. And if we put that in the calculator, we get 858.83 for the area of that sector. All right. And the last part of this chapter, or this section, involves linear speed and angular speed. Linear speed is how the position changes. So how this piece, how fast that's moving in space. Whereas the angular speed is how this measurement is changing over time. So we have this formula for linear speed, this formula for angular speed. Also, going by what we just did with our arc length, S equals R theta. So we could plug that in for V and have it equal that. W equals theta over T. So we could plug that in. So we have 3 forms for the linear speed. Depending on what we know, different ones are easier to use. So those formulas are there. They'll be given to you to use on the test, but you need to know how to use them. Okay, suppose P is a point on a circle with the radius 10 centimeters. So we've got a circle, P, 10 centimeters. And ray OP is rotating with angular speed of pi over 18. So that means the angle is changing with that speed. So if we want to find the measure of the angle at 6 seconds, we're going to use our W formula, which is theta over T. Well, they told us W is pi over 18, and we know T is 6 seconds, so we can multiply both sides by 6 to get the theta alone, and 6 times pi over 18 is going to equal theta. And we can reduce that. They're both divisible by 6. So pi over 3 in radians is the measure of that angle. And if you remember back to that unit circle there, pi over 3 is 60 degrees. So whether it asks for you in radians or degrees, you can get both. B wants us to find S. So find the arc length at 6 seconds. Well, we just found theta, and the formula for S is radius times theta. So the radius is 10, and we just said theta was pi over 3. So if we multiply that out, we get 10 pi over 3 centimeters, if they want exact. And if they want you to actually estimate, you would do 10 pi divided by 3 and get 10.47 centimeters. And finally, find the linear speed. So we have our 3 choices for V. We have S over T, R theta over T, but we already found S, so why would we use that? Or RW. So we can use any of them, but since we found S and we have W, and we have T, that's going to be the simplest to just plug in. V equals S over T. So our S was 10 pi over 3, and our T was 6 seconds. So if you do 10 pi over 3 divided by 1/6, or divided by 6 is like multiplying by 1/6. So you get 10 pi over 18, which reduces to 5 pi over 9. If you had done it with your rounded value, 10.47 divided by 6, you'd get 1.745. And if you plug 5 pi divided by 9, you get the same thing in the calculator. So you have your exact version and your approximate version. All right, you can also use revolutions to go the other way. So a belt runs a pulley. So you've got this pulley here, and there's a belt that's going around it and making it move. It has a radius of 6 and spins 80 times per minute. So we want to find the angular speed in radians per second. So 1 revolution is all the way around the circle. So that would be 2 pi radians. And it does that 80 times per minute. So we're going to do our 80 times per minute times 2 pi, and that gives us 160 pi per minute. Now we want to do seconds. They say seconds. So there's 60 seconds in a minute. We're going to divide by 60, and we end up with 8 pi over 3. If we reduced those, they're both divisible by 20, and you get 8 pi over 3. Now we want linear speed in centimeters per second. So we know that's V. We're going to want to use the W because that's what we just found. And our radius is 6. So we have 6 times that 8 pi over 3 that we just found, which is 48 pi over 3, which is 16 pi. But if 16 pi doesn't mean much, so if you actually type it out, that's about 50 centimeters per second that thing is spinning. So that is 9-1. Let me know if you have any questions.